Jai Jirendra, Namaste and welcome to my channel. Today we are going to solve the 91st question of the problem solving series and the first question of the topic tree. The difficulty level for this question is easy and this question has been asked in Google, Meta, Microsoft, Amazon, Apple, Adobe, Uber and many other companies. Binary tree in order traversal. So we have already covered arrays, linked list, tags, queues, and binary search, which is a technique. But arrays, linked list, tags, queues, these are different types of data structures, but there is one similarity between them, that they are linear data structures, right? But so we saw in linked list there was we had a link from one node to the other, so we had to traverse through all those links. We couldn't traverse through index. But the difference between linked list and binary tree is that binary tree is an hierarchical data structure. That means if I have a one node, it can have many. So first it's tree. So tree is the hierarchical data structure and binary tree is one of the tree where the hierarchy that there could be maximum two children from one node. Okay, the hierarchy is two, and then it can have two more, then it can have two more. So since it's binary, one and two, so this is the hierarchy. So like folders, when we have a folder, so we have a subfolder, right? So this is a hierarchy in trees which are not there in the other data structures that we have looked. So here you see the definition of this tree node that we have taken, struct t node, where there is a value, like we had the value in the linked list, but there is a left and the right pointer of same data type tree node. Okay, so these are its subtree. Okay, so say this is the beginning of the tree. Let's look at the example that we have here. So you see that this is the tree, right? So it is the root node, the beginning of the node. The value is 1, okay, like this 1. And it has a subtree, that is the left subtree, and this is the right subtree, right? It starts from here. And it again has a hierarchy of 4 and 5. This 2 has a left subtree, whose root is 4, and it has a right subtree whose root is 5, and then again it has subtree. So there is a hierarchy, right? So from root we can go to left, then or we can go to right. In linked list, single linked list, we only had one option, right? We used to travel in one direction. But here we have an option of either going to left and continue going to left, or we can go to right, or we can go left then right, but there is no link. We have to go left and then come back and we go to right. There could be different traversal technique. One of the traversal technique is in-order traversal technique. So there is, I know these things you know, just I am revising it. We'll come to the solution. So I believe you know these things. You have already studied the data structures topic. Here this playlist is on problem solving. So I'm just giving a basic idea here that pre-order traversal, in pre-order traversal of the binary tree, we first travel the root and then we travel its left subtree and then travel its right subtree. In post-order traversal we first traverse the left subtree, then we traverse the right subtree and then we go to the root. But in order traversal, we first travel the left subtree, then we go to the root and then we travel the right subtree, right? So this is the way we travel. So what would be the in-order traversal of the example that is given here? So we are at the root, okay? But we would like to travel the left subtree of this before traveling this root, okay? So we go to the left. We see, okay, again we have a left. So we again go to the left. But here, do they have anything left? Is there any left here? It doesn't have any left subtree. So after left, what comes? After left, root comes. So we have this root 4. So this will come over here, okay? Now for this left we have traveled. So we go back. What we have? We have 2, which is the root, right? We already traveled its left part. So we will write this 2 here. Now left root, can we go up? No, we can't, because the whole left subtree has not been traveled. Until and unless we travel the whole left subtree, then only we can go up, right? So for this one left we have traveled, for this one root we have traveled, then we go to its right part. So we go to the right, so this is 5 and we see that okay, it has a left subtree which we have not traveled. So we go to the left subtree, we get 6, it doesn't have any children, so we traverse this 6. So we go back, so 5 is there, it does, we already have traveled its left, so it is the root, we travel this, and then we go to the right it is 7, it doesn't have any children, we print it, and once we have traveled this, we go back, we have already traveled this left subtree, so we travel the right subtree, right? So it is 1. Now we go to the right part. So what is there in right it is root 3. Does it has left subtree? No, it doesn't have a left subtree, it has a right subtree. So left is not there, then after left root comes, so we will print root, so 3 will be printed. And then what will go? Left is not there, root we have printed, we go to the right. What do you have in right? 8. But before that we check, okay, is there any left subtree of 8? Yes, left subtree is there. So we travel the left subtree 9. We go back. It doesn't have right anyway we don't want to travel the right. First we have to travel root. So we travel the root. It doesn't have any right. We go up. So this is traveled already. It's root and it's right child. So we go up and we see, okay, the root is already traveled. So we have traveled the right subtree, whole of the right subtree. We went back to the main function 1. So this is the ending. Okay. So 4, 2, 6, 5, 7, 1, 3, 9, 8. So this should be the in-order traversal of this one. So we need to solve this problem. How do we do an in-order traversal? So the main thing is that we first check, when we are at the root, we first check does it has a left subtree. So once we check it, if it has a left subtree, then again we check does that node has a left subtree. Then once we check, so we repeat the same thing. When we find that it doesn't have any left subtree, like this 4, it doesn't have any left subtree, what do? We print this 4. Okay. Then we see whether it has the right subtree or not. It doesn't have the right subtree, then we go back. If it has the right subtree, we will go to the right subtree. So there is a pattern, right? And there is a hierarchy. Same thing we are doing. So first we are calling this in order, going to the left part, and then going to the left part until and unless left is, we don't have a left subtree. Once we get it, we print the value. If it, and then what do? Once we print the value, we go to the right subtree. Okay. So this is a recursion, right? We are going to the left also, we are printing the value, and then we are going to the right also. So we need to call this, do this in the recursion, right? There is a recursion, we understand the recursion. What is the base case of the recursion? When the root is null, when the value or everything is printed, like it doesn't have anything, then we return it, okay? Like you'll understand. So like 6. So when it is in 6 and then it goes to the left subtree, it doesn't have anything, right? So it has to return, right? It has to return and terminate. It doesn't have right subtree. So when the root is null, it has to terminate, right? There should be a termination condition. So let's code it. So we need to return it in vector. So we'll store whatever the traversal is there in the vector. So let's take a vector of int result. Okay. We have done this. Now what do? We have to return result, right? At the end, this result would be our answer. And what we do, we write a function in order. Okay. In order, where we pass this root and also pass the result, because we want to store this the in order traversal in this result. Okay. And since it is a vector, we want this. We can't make this recursive, right? So we will pass this, we'll make a new function which will be a void function which will be recursive, and then we will get our in-order traversal in the result from that in a recursive function, and then we will return it. Okay. So let's code this in-order function, recursive function, void in-order. Okay. Tree node strict root and this vector of int ampersand, say res, we name it as res, anything you can do, right? So now what would be our base case if there is no value, if root is equal to null, right? Then we have to terminate, right? So this would return, no, nothing would be done, function would be closed. Otherwise, what do? We travel to the left part, left of the tree. So we call Inorder root left, okay? So we go to the left part and then we pass the result also, okay, this result. Now once it gets the left, okay, it gets the left. Once we are at the left and then say here in the, say example here, 1 called 2, okay, here, since it is not null, it called 2. Then 2 called 4, okay, because it is not null, 2 called 4. Now this 4 has come to this Inorder function. So now root equal to null, it is not null. So it would call root left, okay. So now root left, when it would call, it would be null. So it would return nothing. So since this is nothing, then what do? We have whatever its values are there, if it has to print, it would have printed. But then this needs to be printed, right? So once you call this Inorder, we have to follow this path, left, root, right. So whatever we have value comes here, we add that to our result dot push back. Once we do for the left, we print this root. What do we put? Root value, the value of this, right? Val. So this is done. So root left, whatever the value is there, we print. Everything would be done recursively. So once the value is printed, for when we traverse the left subtree, print the value whatever it is there, and then we go to the right subtree, right? Okay, like here, when Inorder comes, this gets printed whatever it is there. Then it would go to the, after getting it printed, it would go to its, so here it was there. So 5, 6 things would have been printed, and it would print 5 also, where it called this, after calling this root left every operation, and then it would go to the right. We need to go to the right. So similarly, we will call root right, okay, and then we will pass the result, and then we can stop it, okay. So this will give us the Inorder traversal. How? Let's do a dry run before going to a code walkthrough. Okay, let's do the dry run for this example itself. Okay, so we pass this root 1 and the result we have, okay. Now 1 is not null, so it called root left, it called this 2, again it called this 4 recursively, again it called the left was not there, it was returned. So once this was returned for this result root value, 4 gets printed, here 4 gets printed. Now it called its root right, it doesn't have root right, okay. So this is done. So this thing would be done here. So now whatever the result was there, this was called for 2, okay. So 4 thing was done, this one's called for 2, so it goes to here, okay, because this 2 called root left, okay. So now when this 2 called root left, it would print the whatever the result was there 2. So 2 gets printed and it goes to its root right, so it goes to 5. Same thing is done for this case also, 5 also. So all the nodes, same thing would be done, and finally we will get this result. Okay, I hope you have understood the question. The link to the question is given in the description. Please try it yourself and then come to my code walkthrough session. Here is the code walkthrough of the 91st question and the first question of the topic tree, binary tree Inorder traversal in the lead code platform. Okay, you can see this example, 1, 2, 3 it's given. So we go to the left, it doesn't have the left. So 1 gets printed, it goes to the right, and then right says okay it has left, so 1, 3, 2 will be the answer, right? So we have already discussed this example, okay. So you can see the code is same as what we have discussed, okay. So let's directly submit this. So okay, it has been accepted, and you can see the companies that have asked these questions are these many companies. Recently they have asked this question. It's very simple, it's very basic, okay. So okay, see you also in the next video where I'll be explaining the 92nd question of the problem solving series and the second question of the topic tree. Jai Jinendra.